All right, everyone. In today's video, we're moving on to section 3.4, and I'm calling it part 1. And really the main idea for today is that we're going to be solving equations still, but now instead of having a variable on just one side of the equation, we're going to be solving equations that have variables on both sides. So you can see that's our learning target for today, so solving equations with variables on both sides of the equal sign. So just like it sounds, right, we're going to have equations now that have variables on both sides. To solve these equations, we need to collect all of the variable terms on one side of the equation, and then we need to get all of our constant terms on the other side of the equation. And remember, our constants are just the numbers that are by themselves. Now, the main point that I want to make here is that it does not matter which side of the equation you move your variables to. No matter which side you move them to, you'll get the same answer. But for the purposes of this video, I'm going to show you I'm always going to move my variables to the left-hand side, just because personally that's where I like to move them. So, for example 1, here we go. Now, we know we always draw our line down the middle to separate our left and our right-hand side. And so again, I see that I have a variable term on the left side and on the right-hand side. And my goal is to get all of my variables over here on the left side of my line. So I realize that if I want all of my variables over here, the first thing I have to do is move over this 3x. So to do that, I'm going to subtract 3x on both sides. So on this side, now I have 7x minus 3x. Notice I put my x terms under the x because I want to put those like terms together. So 7x minus 3x is going to give me 4x. And then I bring down my plus 4. On this side, now my x's are gone and I just have 20. And hopefully what you notice here is now we're just down to a basic two-step equation. So we know when we have a two-step equation, the first thing we do is we find the side that has the variable. So here I'm focused on the left side, and I know I need to move the constant first. So the first thing I move is the number that's by itself, which is 4. So to move that over, I'm going to subtract 4 from both sides. That cancels, and I'm left with 4x. And on this side of the equation, I have 16. Now I'm down to just my most basic one-step equation. I'm going to divide by 4, and I get x is equal to 4. Now, just to prove to you that it doesn't matter which side we move to, I'm going to do the same problem, but this time I'm going to move my variables to the right-hand side. So in this case, if I want my variables on the right, my 7x needs to move over. So I'm going to subtract 7x from both sides. So these go away. I have to bring down my 4. Now I have 3 minus 7. And so I have to be really careful about my sign. 3 minus 7 gives me a negative 4, and I bring my x down. And then I'm going to bring down the plus 20. So now again, I have a basic two-step equation. If I look on the side with my variable and I find that constant, that's what I need to move first. So now I'm going to subtract 20 from both sides. On this side, 4 minus 20 gives me a negative 16. I'm going to extend my line. Over here, the 20s go away, so I have a negative 4x left. I'm going to divide by a negative 4, divide by that same number and sign. And sure enough, negative 16 divided by negative 4 gives me a positive 4. So my x is equal to 4. So again, it does not matter whether you move to the right or the left. But as we go through the rest of the examples, I'm just going to show with moving it over to the left-hand side. So let's look at example number 2. Okay, my equation is here. You can see I again have an x term on both sides of the equation. I want my variables on the left-hand side here. So I know that my 8x has to move over. So I'm going to subtract 8x from both sides. Extend this down a bit. So now I have -2 minus 8. Again, please use those calculators and double check those signs. So I get a -10x. I'm going to bring down my -7. And now my 8x's are gone, and I have a +3 to bring down. So now I'm going to move my constant away from my variable by adding 7. So I have -10x left. And then over on this side, 3 plus 7 gives me a +10. Lastly, I'm going to divide by a -10. And I get x equals -1. So that's how these equations with variables on both sides are going to work. So let's see, we'll do 2 more examples to make sure we've got this down, and then you'll have some time in class to practice with it. Now there is a note at the top of the next page. Okay, and it says if we collect the variables on the side with the larger coefficient, we will get a positive coefficient of the variable. So some people like working with positive numbers better, but again, this is the main point here that I want to make. No matter what side you move the variables to, you will get the same answer. So it's largely just a matter of which side you like to work on. So let's do 2 more examples. We won't worry for the sake of this video about writing out the steps. I just want to go through the problem. And remember, I'm always moving my variable to the left-hand side. Now in this case, this one's a little bit different because what I notice here is if I want to move over this x term over to my other side, I have to be careful. Since this is a -2x, to move it, I'm going to add 2x. And again, x's go under x's, so I make sure I'm combining like terms correctly. So now I have 7x plus 2 more x's gives me 9x plus 19. Over here, those cancel, and I bring down my 55. Now again, we're back to a 2-step equation. So I'm going to subtract my 19, so all my constants end up on the right-hand side. I get 9x. 55 minus 19 is going to give me 36. And then since this is 9 times x, I know to undo that, I divide by 9. And when I do that, I get x is equal to 4. Now, something I haven't been doing but probably should is my check step here. So now I actually need to check. I have an x to fill in on both sides. So what I need to check, here's my original equation, 7x plus 19 equals -2x plus 55. So let's go ahead and substitute 4 and make sure both sides are equal. So again, x gets replaced with 4 on this left side. And now I have to replace it on the right side. Okay, and now we're going to use our calculator. I'm going to enter it exactly as it is on my paper. So here's my calculator. I have 7 times 4 plus 19. So my left-hand side is equal to 47. And we hope, if we did this correctly, our right side should equal the same thing. So I'm going to do -2 times 4 and then plus 55. Whoops. -2 times 4 plus 55. is also 47, so our answer checks out. So, one more problem, and again, this has a little twist in it. I've been saying up until now that I like to move the variable over to the left-hand side. However, when I look at example number 4, I notice that the variable is already by itself here on the right-hand side. If I were to move that over to the left, now everything would be on the left-hand side, which isn't what I want. So since the y's are already by themselves here, I'm going to move over these 9 y's as well. So in this case, it actually makes more sense to move our variables over to the right. They're going to join these variables that are already by themselves. So I'm going to add 9y on both sides. Now these cancel out. Oh, you know what? To make this nicer, let's make this a 90. So now those are going to cancel out. I'm going to bring down my 90. On this side, I have 6 plus 9 gives me a 15y. And now I'm going to divide both sides by 15. And when I do that, I get 6. So my y is equal to 6. And of course, we're going to check this. So my original equation was 90 minus 9y. And we say that's equal to 6y. So let's go ahead and substitute 6 in both places where we see a y. So 90 minus 9 times 6. And we think that should be equal to 6 times 6. So here my calculator is going to help me out. I'm going to do 90 minus 9 times 6. I get 36 on the left side. And then 6 times 6 also gives me 36. So our answer checks. So that is how we solve equations with variables on both sides. And you'll have a practice worksheet to make sure you've got it.